Welcome, everyone, to a special edition of our Night Matters webinar series featuring Mark Jobe, President Emeritus of the Minnesota Astronomical Society, member of DarkSky Chapter, Starry Skies North, and owner and operator of two observatories in Minnesota and Texas. Mark will be sharing today some really interesting information about astrophotography and share some amazing imagery from his observatories and other about shooting in light polluted skies and non-light polluted skies. Without further ado, Mark, if you want to get started, let's let it rip.
So my name is Mark Jobe. Chris is right. I'm a past president of the Minnesota Astronomical Society. I've been a member of that society for more than a decade. Um, it's all their fault. That's why I got into astrophotography. Um, they they they're very good at what they do. So I appreciate them. And as I've gone along, I've discovered things that I maybe not have been aware of as much, and that's light pollution. And then I found it Starry Skies North. Um, I was always aware of uh, Dark Sky International for a long time. I know our club contributes and associates with them, but you know, also about me is the fact that I do astrophotography. I'm having trouble with my mouse. I'll put that next slide. I'll tab. But editor, I'll have some fun editing that. So about me, lifelong astronomer. And I say that because I grew up in the central part of North Dakota. Um, I was born in Minnesota, but I grew up in the central part of North Dakota. And as long as I can remember, the sky was always dark. Um, I was always able to see, Northern Lights, Milky Way, fondest memories of my aunt and uncle showing me constellations and things like that. So that goes all the way back to my childhood. Never really had any equipment or telescopes or binoculars or anything like that as a child growing up in North Dakota. Um, those I have acquired later since I became a member of the Astronomical Society. And, you know, I own a few telescopes. And in the last 10 years or so, I've kind of been learning and getting into astrophotography, and I'm really enjoying it. Um, it's not that I don't enjoy um, just going out and looking through a telescope either, but I'm discovering that astrophotography pretty much consumes all my time. And I do a lot of outreach, and that's where I get the opportunity to look through a telescope again and share those things and do that kind of thing. So uh, my first slide here is I just want to show. Let's see if I can get that to run. There we go. So this is a time lapse that I took of the Milky Way rising, basically. I could have added a bunch more slides ahead of that would have showed the Milky Way coming out of the trees. Um, but that was, so these images were taken in the hill country of Texas, northwest of Austin, probably 90 minutes, maybe something like that, maybe almost 2 hours. And it's a couple of years ago, in the spring. Let me see if I can get that to play again. There we go. Um, and it's quite fascinating. I mean, I could sit and watch this all day long, because it's one of those things that I love to do, and this is something that I cannot do from my house, and I'll get into more and more about that later. But you know, that's where I want to go. So, amateur astronomer. Yes, I am. I like looking at the night sky. If it's a clear night, I'm going to go out, and even if I just spend 5 minutes out looking at things. There's always planets. There's always a planet to look for. And it seems like lately it's when it's clear, the moon is there. So I'll spend some time looking at the moon. But my real passion is astrophotography. And it is getting out with a camera, and it doesn't matter if it's just a simple camera with a lens and shooting, the Milky Way, or just shooting constellations, or just shooting a section of the sky just to see what's there. For me, a 20-second exposure is kind of cool. And I say 20 seconds because you go much longer than that. Well, usually the image fills up with a bunch of light, um, especially if the moon is around, which is a really big light polluter. But you know, we can live with that one because it goes away. Yeah, but it's if I go much longer than 20 seconds, then I get star trails, and star trails aren't as interesting unless that's what you're after. Um, but yeah, I mean, I will. I'm going to talk about pictures, and here's one. Uh, it's the Trifid Nebula. It's known as Messier 20. Charles Messier, a famous comet hunter, discovered this one. This was number 20 on his list of things that he had made a note of its position and its brightness, and he added it to a table and says, I don't ever have to look at that again in that spot because I know that that's not a comet. Um, and I think that's obvious. But it's a very cool image. There's actually three different types of things in there. There's a reflection nebula, which is the blue part that you see that is highlighted and lit up by basically these stars are behind this gas that lights that gas up. And then this pink part is a emission nebula. It's mostly hydrogen alpha, glows red, for us in our sensors, and you know, um, it's mostly lit up by the stars around it. It's actually a birthplace of more stars. There's a lot of things happening. And then the other piece is this little cluster up here at the up at the upper left center, um, which is it's a bonus, is what I call it. So it's kind of cool. So this is it's identified as IC 405. So it's a IC catalog. I forget what the I stands for, but the C is catalog, obviously. Um, but this is also a reflection of it. They call it the flaming star nebula, and really it looks like this star is on fire. Um, Heavy hydrogen alpha all around it. There's some oxygen 3 in there also. But this is in the constellation Auriga. And I guess if I forgot to say it, but the Messier 20 is in Sagittarius. Um, and that's kind of hard for me to shoot from Minnesota because it doesn't get very high in the summer, and it doesn't give me a very big window to take an image of it. So I shot that actually in my observatory in Texas. And so this one is in Auriga. The next one I have is the Crescent Nebula, and it resides in the constellation of Cygnus. This actually has a NGC number, NGC 6888, first spotted by William Herschel in 1792. This one's unique because it's made up of a Wolf-Rayet star. Um, they're the hottest known stars, and it creates a very nice image. So I kind of enjoyed this one. But this one, I shot this one from my backyard observatory here in Minnesota. So let's move on to talk about why, why am I concerned about light pollution? What is light pollution doing to me um, personally in my hobby? How is it affecting me? Um, it's I need a darker sky. And years ago, I guess it's already this is 2024, 2018, 6 years ago or so, we started, a friend of mine and I, we started looking for a darker sky. Um, because for me, I'm already having issues with light creeping into my space. So this is about where I live. And as you can see, this is a snippet out of what do you call it? The dark sky map. And it shows pollution that's starting to creep in. I mean, I think I've been living here for over 20 years, and I don't remember what it was when we first moved here because I was so busy with life and raising a child and things like that. So life kind of got in the way. I didn't really pay attention as to how dark it was or wasn't. But I know, like in the last 10 years or so or more, that it's getting brighter. And I know the culprit. The culprit's right there. I live in Buffalo, Minnesota. Um, so I know, the city is growing. There's houses going up everywhere. Um, and they're bringing light. Um, I get it. But they're interfering also with my hobby. So how much farther can I go? I guess I have one more slide here. So this is my reading, 20.35. This is a sky quality meter reading. I use this to decide, or not decide, but to give me an idea of how dark the sky is. This was a recent reading. So to kind of give you an idea, even if I go a mile and a half east of my home, on that last previous map, it said that I was in a Bortle class 4 region, and this is based on data from, well, almost 10 years ago. Um, if you just go a mile and a half east, it changes one whole Bortle, and if you remember if I go back a couple slides here, you know, the SQM reading here on this map is 20.55, close to my reading, but not, you know, you can tell that it's getting brighter, because the higher the number is, the darker the sky. So here we are a mile and a half from my house, and it's 19.66 in 2015. I have to believe that today is probably closer to the right at 19. I should walk down there some night and just take a reading. But I think there's a big light there now, on the corner. So it's one of those deals. Is how am I going to get away from the light? And is the light really that bad? I mean, I can still shoot northern lights from my yard. Um, that light strip that you see, that white streak, that's actually I caught the International Space Station that night. Um, as you can see in a couple, if I flip back and forth between two slides, you can also see the aurora changing. That was a bright aurora. That was quite nice. Um, so that was kind of fun that night. I wanted to go shoot it. I wanted to leave my yard and go to a darker place and shoot it, but I actually was operating my observatory that night. So I did not. So, and even in my yard, if I go 1,500 feet farther east, look how much different my sky changes. Even this exposure in my camera is about the same time, same length. You know, Probably around the 12 to 15-second range. Um, you know, Look how much more light pollution I get from the east, and we're not talking about that. This was a long time between the exposures, because it wasn't. It's just that all I did is move. I got basically replaced the sky where I had trees with some light pollution. So it's difficult. Um, so let's talk about boredom. Created by Johnny Bortle. He published in, he came up with this, and it was published for the first time that I know of in February 2001 in Sky and Telescope magazine. It's essentially a scale of brightness, sky brightness, or darkness, however you want to look at it. Um, and as recently as 2014, some people have been a little critical of it, saying that it's not quite as accurate. And I think that's, when you look at this scale and you look at your sky and you compare your sky to this scale, you go, well, I think I think I'm a mortal, whatever. Um, Especially when you're in those middle ranges, 3, 4, 5, 6, um, even my sky, if I walk out at night with no moon and it's clear, I used to always think I was like a 3, but when I start taking my meter and comparing it to his scale and looking at those types of things, you know, I'm finding out that I'm more of a 5 closer to 6 type sky, probably probably more so around the 5. And that's I know it's changing. And so I guess when I talk to my friends and I talk to other people, I like to refer more to the SQM reading because that's a very scientific reading, I guess, in my opinion. And you also have to be careful when you take those readings. I mean, um, make sure that it's after astronomical dark and make sure there's no moon and things like that, um, which is typically what I do to make sure. So that's I don't rely on the Bortle, but it's a the Bortle scale is something that I use to as part of a discussion or kind of gives a level of how dark your sky is, and I think that's the value, to give an idea of what the sky is like. So I've been in search of darker skies. My yard is it's okay. But I know there's creep. I know, the future is coming, and and maybe we can get more education and we can do some things about that. So, what about darker sky? How about Texas? So like I talked about in the early slide with the Milky Way animation, the time lapse. So this is my trip that I took in 2022, 2023, actually, April 2023. We went to Me and some friends. We went to the hill country of Texas. Um, Meter reading there was 21.4, and that's according to the scale, that's in there as a rural sky, rural 3. And when you look at the dark sky map, it's they say it's that specific spot is a portal 2, 21.95, versus 21.4. You think that that's not that much, but it's the difference between a 2 and a 3. So if I had the grade, I would say that this spot, based on my meter reading, is a portal 3. Um, and but it's dark. It's adequate. It's good. I'll live with it. But as you can see from this map, you can see that there's creep coming. There's light coming from, I mean, right behind that scale is Llano. Llano is it's a small town. There's less than around 1,500 people that live there. Um, yeah, it's happening, and when you look at this picture you go, okay, I can see 2 light bulbs in this image, which is one picture out of that time lapse, and there's 2 light domes in there. One of them is Llano, which is directly to the east behind that tree, behind this tree, and then this is Fredericksburg. Well, if you go back to this picture, our spot is here. Fredericksburg is down here. Llano is back there. Um, Fredericksburg is 45 miles away, approximately. Um, so you have to get away from those lights, and by quite a few miles. You got to, and maybe they're, in defense of those two cities, I'll defend them a little bit. Maybe there was some sky glow, maybe there was some high clouds or some, maybe fog or something like that that was causing uh, a reflection of that light. But still, wouldn't it be kind of cool if you couldn't see those at all because they had proper lights? So in Texas, I can get images like this. Um, this was shot with just a simple 5-inch refractor. I mean, there's lots of data there. I also used filters and things like that to keep out any light that was there. This next one was also shot from Texas. I guess everybody recognizes the Horsehead, and so the Horsehead is in the constellation of Orion. You can see right here that there's a there's a star that's off the sensor. It's not in the field of view, but probably still is shining within the telescope, but not that light wasn't hitting the sensor. And it did that on purpose because otherwise that would really be bright, and that would have made this image a lot harder to process. But you know, it is what it is, and it's kind of cool. So this is in Orion, and it's just off the tip of the belt of Orion, the bright stars of um, Almanac. So then there's this image, which is also known as the Drunken Dragon. Some of you artists out there probably can see a dragon in there. If I work hard, I can kind of see that this is the dragon's mouth. You can convince me of that, I guess. But after that, I don't really see it. I guess this would be his wings, and maybe because he's upside down, maybe he's drunk. I'm not sure. But another image shot from Texas. It's a very dim image. I don't know if I could do that from my backyard observatory here in Minnesota, just because I have to shoot this in broadband, which means that I use a monochrome camera. It is shot with red, green, blue filters, and it's dim. And how much more time would I have to spend on this? This was already 238 images at 300 seconds per image that are stacked and processed from there. You know, would I need more so I could take out more of the background that would wind up filling this image from a 300-second image? I don't know. So it's it's challenge accepted, but it sure would be nice to be able to do it without it. Um, Here's another image. This is the, the heart of the heart is what I like to call is what I had named it. The Heart and Soul Nebula, which are up in Cygnus, or is it? Wait a minute. No, they're in Cassiopeia, I believe. Uh, you know, but I shot this in narrowband. I shot this in my backyard. Um, it was a blast. So I mean, using narrowband filters, and I say narrowband is hydrogen alpha and oxygen 3, which are very very specific frequencies of light, wavelengths of light, and you can that then I can filter out all the light pollution. Um, so you know, so I also talk about how about closer to home, Minnesota State Park, Loch Keep-Harl, Western Minnesota, Southwest. I used to think it was really dark until I took my meter down there, and then I learned that it's 20.9. Well, it's not that much better than my house. I shot this image of the Milky Way. The lights that you see on the bottom where the trees are lit up, that's actually the shower. And restroom facility within the park. The lights farther off to the right over here are actually a city that's probably about, I want to say like 20, 25 miles away, something like that. Um, and again, I'll defend those lights a little bit because I know that it was hazy that night. This was the fall. There was lots of harvesting going on, so there's added added particulate in the sky. It was a little humid because it was kind of nice. So because this is like late September, October for us here in Minnesota, that those it's a nice night, and so there was probably some humidity. So challenges. I got the Milky Way. I could crop that nice and crop out the horizon. But I'd rather have those trees in there. It would be kind of cool to have those trees in there showing up as black rather than bright white. Um, Also that same trip that I was out there, we also saw the aurora. And you could see the importance of having uh, being able to see aurora. Now, if that was a city up there to the north, because you can see the Big Dipper, you can see Polaris and the Little Dipper is right here. So you look at that and you go, well, if there's light pollution there, we never would have seen aurora. I actually had wound up with a pretty nice time lapse of this aurora because it got a lot brighter. It didn't get very tall though. I mean, and I say tall because it didn't get much above the bucket of the Big Dipper that night, but it put on a pretty good show. Probably wouldn't have been able to see it, or probably wouldn't have been as interesting had there been light pollution. We need to go talk to this park because these are their main park offices, and as you can see here, it is midnight during the week, and the lights are still on. So why can't those lights be on the sensor? And I realize that communication towers and things like that, cell towers and whatever else that was, and another tower in the distance, you know, I realize those have to be there. I'll take the red light. Um, Photoshop's got some fancy tools. We could go in and knock out those lights because they're not really a big deal. And then, more education to the farmers that are out there too. We could get rid of all those lights on the surface of the horizon there too, if they were aware, because I'm sure they have no idea. So how about, like I said, I grew up in the central part of North Dakota. Um, I get out there periodically. We still have family out there, my wife and I. Um, and you know, this was this was a different camera. This is like my older camera. So I was looking for Milky Way shots specifically, and this is what I found. But there again, here we are. We got haze and some low clouds and things like that. I know there's a city about 25 miles away again, maybe less, maybe more like 18, 19, something like that way. Um, but then we got the farms and the farmers, they have to have light. This was taken, I believe, in the summer, you know, so they're working, they're busy, they work all the time. They've got, but here again, if they had proper lighting, we we wouldn't have the distraction. It's not that it's messing up the sky, but it's more of a distraction. It's it's in my camera, so you know, that's a distraction. Uh, you know, this is actually from my wife's family farm, and this is one of those nights I was actually doing some astrophotography with my telescope and my camera, and I was wondering why all of a sudden it was so bright. And I going, why was I having a hard time seeing the object that I was taking? Well, here is the light polluter. Um, the northern lights showed up, and this this was a pretty good image. I shot it again later at another time so that we could see the Milky Way on the old windmill. and this is on the farm where my wife grew up. So it's dark there. Um, I was looking for some readings. I always take readings, but I need to do a better job of logging them. But again, this is probably around that 21, 25. I don't think I've ever gotten a 22 reading out there, you know. Um, but I would say that this is what you would say is dark. Um, Friends of mine, we used to talk about the Milky Way, that when you get into a dark place where it is so dark, you know, actually the Milky Way is a little bit annoying. It's so bright because it actually has and can have some effect on your night vision. I mean, I'm not complaining. I'll take it. Um, I'll take light pollution from the Milky Way versus light pollution from some artificial light, or a city that's nearby. So this was cool. This was a good night. I like to shoot the moon. It's, I mean, if I have to have it, I'll take advantage of it. And if I'm not busy or I'm fooling around waiting, usually I'm waiting for it to get dark. So if the moon is there, I'll take a couple shots at it, just to get something. This is one that I thought turned out pretty good. I also like to chase transits of the International Space Station. So if you can see on the image, there's three. This is a composite image where I'd captured the International Space Station going across the face of the moon. Um, I have no idea where this was taken, or when I took it. I just know it's part of my collection, and I like to show it off. Going, hey, look, I got the International Space Station. Um, so that was kind of cool. Um, but in my backyard, I can also get, this is probably the best picture I ever took of Mars. It was, uh, it was, you know, I was just, it was one of those nights where Mars was high. It was nice and clear, and I actually was interested in trying to capture it. And, you can see you can see the polar cap there, and you can see some details of the canyons and the caverns that are on there. And, the smoother parts are basically flatlands. So it's hard here in Minnesota because we don't have the greatest skies. It's and I'll talk about that more in a little bit, where the sky is the quality of the sky, the stillness of the sky is not the greatest. And so images like this are a challenge. But here's a picture that I also took at a star party one night. We were just doing some live imaging of objects, and just letting people see what's possible, or what are they not seeing with their eyes. um, Obviously it's an Andromeda galaxy. It's obvious to me. Obvious it is to everybody else, but there's three galaxies there. It turned out quite good. And so I saved it, and actually I think I passed it out to a few people as a digital image, and it was great. So this was taken even in a suburban type environment. This is on that border, almost a portal 6. But with proper processing, we were able to take out any of the artifacts related to um, uh, light pollution. And we were also probably, if I remember correctly, this was in the fall, so it was quite high in the sky. So we were going straight up. So that's always a bonus. Um, Here's another image in my backyard. The Cygnus wall. It's just narrow band filters, hydrogen alpha and oxygen 3 again. Um, Hydrogen here is I guess I have a note that says it's 656 nanometers is the band pass of that filter, and oxygen 3 is around 500 nanometers. So those two frequencies, those two wavelengths of light, that's all I was looking at, and it works quite nice to get that. Again, another picture of the horse head, but this time from my backyard. Um, uh, uh, I was after this little this little reflection nebula here, and I just put it off to the side, and the Horsehead is obviously as the centerpiece. You know, a much bigger telescope, much bigger ability to gather light. I didn't need as much time, and it's you know, I only have like 4 or 5, 6 hours, 6 hours or so in this image, so worked out decent. But again, got any more time, I don't know. It would have been a struggle to get the background out. Everybody needs a hamburger. And here's the hamburger galaxy. This is part of the Leo triplet, taken from my backyard again. So Northern Lights from near my backyard. You know, in this case, you know, I mean, there's snow on the ground. Obviously, you can see that in the front. The aurora. Um, and actually, I think in this image, the direction that this was taken, there really are no close towns. There is a town. You can kind of see that there's a little dome right here. But also the exposure of this image is only probably 12 seconds maybe or so. You know, so here a little light pollution wouldn't be a big deal, but you know, it makes it so much better. It makes it so much crisper, so much better to see. So, you know, my search for dark skies. Well, how about a remote observatory in Texas? You know, a friend of mine and I, we got together and we started brainstorming. You know, we wanted to get out of the Minnesota sky because the Minnesota sky doesn't give us as many opportunities because of poor weather, uh, poor sky quality, as we talk about sky quality in perspective of seeing. The seeing is bad because we live, you know, as we know, the jet just flies over us, the jet stream, and that's makes a turbulent atmosphere. It makes it hard to do really good astrophotography. And if you don't believe me, take a look at Hubble images, which you know, Hubble just celebrated a birthday of its launch yesterday, 1895, I believe. You know, you look at those images, and those stars are just they're just pinpoints, and that's what we want. And the best way for us to get that is quiet skies. Uh, you know, so we looked at Texas. We considered it, and actually, we considered it a lot. Um, it's 15 degrees farther south, so we get more of the southern sky. Um, and so we picked out a spot. And we found an opportunity with some land in in this area. We learned about this, and you know, as we do our investigation, we find out that oh, look, it's we called it a portal two. Um, it's not quite that good. It's more on the edge. It's like I'll say 2.5, um, something like that, because we're around 21.4 ish. You know, so you know, 2.5, 3, somewhere in there. You know, it gives us more opportunities. On the left is the amount of dark we get where the black is that we get over the course of a year versus here in Minnesota. You know, unfortunately, when we get the most darkness, it's also winter, which means then that it's also colder, and you know, we have snow and we have clouds and we have, you know, some of the worst months, November, December, January, February, some of the worst months for clouds here in Minnesota. So more opportunities, more darkness, darker sky. So we chose this place. It's actually a group. It's actually a community of a bunch of telescopes and a bunch of observatories. In 2018, this is the way it looked before we added our place. When we added our place here on on the end of the row, and then they added some more over here. This is the way it looks today. It's great here. So we built this observatory. As you can see, we also built one of the smaller observatories, and it fits our need. It's so it's a we have an agreement with the organization that we own everything from the dirt up, and it works for us. We added, after it was all built, we added a couple telescopes. Mine here on the left is a 5-inch refractor, perfect for taking nice, pretty pictures. The scope on the right is my partner in crime, Russ Durkee. He is uh, a teacher at I get it wrong. It's either Wayzata or Minnetonka. I think it's Minnetonka. Um, so he actually uses his telescope and data that he collects with his students. So this is the way it looks. It's almost like this today yet, but this is where it was after we got it all set up and running. As you can see, it was a cloudy day the day that roof was opened, but that's what can we say? It can be cloudy during the day. So a remote observatory, everybody go, oh no, remote. You know, you're gonna entrust an observatory that's 1,200 miles away, and you're gonna open the roof, and that means you have to close the roof. You have to control a telescope. Um, so we have we have great tools. These guys, Interactive Astronomy, have developed these tools to monitor the sky because I mean when we're running the camera, it's difficult to even watching satellites and all the other things that we do to be able to pay attention as to it's cloudy whatever. But so this sky alert device here will monitor the clouds, keeps track of it. We measure sky temperature, as you can see here, or sky temperature right here. That's how, hang on one second, get a drink. By knowing the sky temperature, we know whether or not there's clouds. So if there's a cloud, as you can see in this picture, um, if it's cloudy, the sky will be warmer. If the sky is clear, it'll be cooler. Because if you think about it, space is very cold, and if we're using an infrared thermometer, we can measure temperature in the sky, and that's what that sky alert does. So we know when clouds are coming. Most importantly, we want to know when it's cloudy so that we can quick close and uh, protect our equipment. We definitely don't want any rain on our telescope, but we also have a sensor that will detect if it's raining. We also have our equipment set up so that if it senses rain, if it senses clouds for too long of a period of time, it will just put the telescopes in a position so that they're parked, so that the roof can close, so that then the roof closes and everything is protected. We don't have to worry anymore. But as you can imagine, there's a lot of bells and whistles and buttons that have to go right so that we can operate this from 1,200 miles away. And so far so good. We're doing all right. Russ has got a 20-inch plane wave that he uses for um, um, doing light curves on asteroids. Um, you know, and I think this is probably from 2018, 2019, something like that. He had already collected data within a year or two for 3 papers, and he was working on some other projects. And I think right now he's working on one single project. I don't know what it is, but I know it's something similar. So it's it's cool. He's doing science. He might be working on making sure that we know when we're going to get hit by the next asteroid. So that's kind of cool. I don't know if we want to know or not, but yes, maybe we can divert it. I'll let somebody else worry about that. But he gets down there in the 17 magnitude star area is and he does that. I mean, it's his equipment is incredible. He could do pretty pictures if he wanted, but I guess he's doing science, so I'll let him do science. I'll take care of the pretty pictures, you know. So here's a couple more. A repeat there of the Horsehead Nebula. Um, this is a jellyfish nebula. You can kind of see it as a jellyfish, I guess. There's that drunken dragon again. There's a galaxy that I shot from down there. Um, that's what is it? That's oh, lost my head. Don't have a note on it. So, but it's a bright galaxy. I mean, from here in Minnesota, when you get to a dark spot, you can see that naked eye. But that's kind of fun to shoot that, just because it's kind of a challenging because it is bright. Brighter objects are a little more of a challenge. So why remote in Texas? Well, we have a darker sky, we have more opportunities, we have a good sky. Our sky is very good quality most of the time when it's clear. I guess it's I guess I usually say a clear sky and a average seeing or good seeing is obviously always better than what we get in Minnesota, because Minnesota, I say we get average or poor most of the time, whereas you know the in Texas we get probably above average to good, even some excellent nights, and it seems like that happens more often than it does here in Minnesota. And this place it's not super expensive for us to operate. It's expensive to get set up. I mean, everybody says, oh, it must cost you a lot of money to operate that far away. And that's not the expensive part. It was all the equipment, the building, and all that, figuring all that other things out. There's 4 computers in there that are basically just operating the building. And then we each have, we probably use part of each one of those 4 computers to operate our telescope. But that's operating the telescope is easy. It's opening and closing and monitoring and taking care of all the other things, because there's also what do we do when the internet is out? What do we do when we can't get connected again to the internet? What are all those things that we have to do to overcome being 1,200 miles away, because there's nobody that lives on site. And we don't know when somebody would be there to help us out. So we would hate to have to leave the roof open for a few days to wait for somebody to come and help us out. So it's a challenge. I think we've done okay. We've definitely increased the number of nights that we can collect data. That was our goal. And also, yeah, that was the main goal. And then the extra goals of being in a darker place and having a better sky, and being able to afford it. That's, those are the goals. So thinking about that, astrophotography can be done, but we need tools. I mean, I can use filters to filter out light pollution. I would hate to have to pick up that observatory and move it to a darker place. That I think that would probably drive me out. That would probably be the end. I probably would continue. And yes, we could go to Arizona, and people ask us, well, why did you go to Arizona? Well, it's about 3 times the cost to operate per month there. It's so it was talked about, but we need these tools. But a better tool is, why can't we just go flip the lights off? Light pollution is one of those things that we have full control of it, and we can change it literally by flipping the switch. That's all it would take. So that's my soapbox. So also recently there is a full solar eclipse, and I was actually in Texas for that. The last, it was great. We were in Texas. We got lucky. We had decent skies for the totality part. We had some clouds before and a lot of clouds after, and actually a little light rain shower. of, before before the eclipse was actually over. So we were kind of, scattered and running around crazy, finding tarps and stuff like that to throw over equipment. Of course, as it would be, as soon as you got all the equipment covered up, it quit raining. So that was okay. I was okay with that. And the fact that at that time we were past totality. I think I got some pretty good shots, not probably as good because I really enjoyed this eclipse. It was long, 4 minutes. It was very bright, as you can see here. The coronas, the, the the corona of the sun was very bright and very big. I mean, it was. I have pictures where it goes all the way out to the edge of the frame. So it was incredible. And by it being that bright, it didn't make it seem like it was as dark. I've heard other people say that, but we also were, we had some clouds, so but my favorite image, daily speeds. It doesn't, being able to see the prominences and the sun shining through these little valleys of the moon, and I say little, you being away from the moon, they're probably not so small. But the next one, everybody asks, after the eclipse, after it's all done, when's the next one? Well, there's one North Dakota to Montana into Canada in 2044. And then I've already talked to my son, and he's already said that I'm around in 2045. He'll take me back to Texas because there's going to be a long duration, 6 minutes, 6 seconds of totality. And I told him, I said, I just want to go to Southern Oklahoma. You don't have to take me all the way to Texas because it'll be visible there. So we'll see where that goes. So any questions? That's all I got. I hope you enjoyed this. It was a pleasure to put this together. It got me thinking about, light pollution and how it affects what I do. I've been aware, but I never ever sat down and put it on paper and really thought about it. And doing this presentation got me going and got me prepared to think about it a little more. So I want to thank Chris for bringing me on, asking me to do this. He asked, I said yes, and that kind of forced me to do it. And that's kind of, I'm outside my normal box. So thanks, Chris.
Yeah, no, thanks, Mark. This was really interesting. Some of those images are just awe-inspiring and just awesome. And thanks again for sharing. Mark Jobe, President Emeritus, Minnesota Astronomical Society, member of Starry Skies North, and so much more. Look forward to seeing more of your images in the future, and hopefully you are around for those next eclipses so we can see what you can capture. So
Yep. Thank
thanks,
you, Chris.
Mark. Yeah.
You bet.